Let us start how to solve a linear differential equation. So a linear differential equation of the form dy by dx plus py is equal to q, where p and q are your constants or functions of x only. Okay, so p and q will be the functions of the independent variable. Okay, and y will be here. The dependent variable will be here. Okay, is known as the first order linear differential equation. Some examples are dy by dx plus py is equal to sin x. So p here is 1, which is constant, and q here is sin x, which is a coefficient of x. Another is dy by dx plus 1 upon xy is equal to e raised to power x. dy by dx plus y upon x log x is equal to 1 upon x. Another form of first order differential equation is linear differential equation is dx upon dy plus p1x is equal to q1. Now here p1 and q1 will be either constants or the functions of independent variable y only, and whereas x here is in the numerator itself. Some examples of this type of differential equation are dx upon dy plus x equal to cos y, or dx upon dy plus minus 2x upon y is equal to y square e raised to power minus y. And to solve this first order linear differential equation of this type, dy by dx plus your py is equal to q. The first one is what we do, we multiply both sides of this equation by the integrating factor. Like we just make it means the form of dy by dx, and we will search out for the integrating factor. So for the form dy by dx plus py is equal to q, for this type of equation, the integrating factor that we will search is your e raised to power integral p dx, which is called as integrating factor. Okay, in short, you should remember just this thing. Solve the first order linear differential equation. So if the linear differential equation is of the form dy by dx plus py equal to q, where p and q are constants or functions of x only, then we will firstly find out the integrating factor, which is e raised to power integral p dx, right? And then we will write the solution of given differential equation as y into integrating factor is equal to your integral q into integrating factor times dx plus c, right? And if the linear differential equation is of this form dx plus dy, dx upon dy plus p1x equal to q1, then in this case the integrating factor will be e raised to power integral p1 dy, and the solution is given by x into integrating factor is equal to integral q1 into integrating factor times dy plus c, right? So let us start solving exercise 9. And the very first question is, it's a very simple question, and clearly you can see that neither it is variable separable, neither it is homogeneous. So clearly it is linear differential equation of form. So form you can see is dy by dx plus py is equal to q, where who is p? P is 2, which is constant, and q is sin x. So we will find firstly the integrating factor. So it is 2 dx, which is e raised to power 2x. Now solution is given by y into integrating factor is equal to q into integrating factor times dx plus c. So y into e raised to power 2x is equal to sin x into e raised to power 2x dx plus c. Now rest is just technique of integration. So how will you integrate when you are having this product function? So we just need to check out the Eilert rule, okay, integration by parts. So you can take first function, then it is your second function, okay, and then you can start. So I will solve this part as separately, e raised to power 2x into sin x dx. So let us take it as I. So it becomes first function integral of second minus integral d dx of first into integral of second whole dx. So this is e raised to power 2x, integral of sin is minus cos x, then it becomes 2e2x into your, this is minus cos, so minus minus will be here, and it is cos x dx. Now again, one more time I'll use integration by parts. We are familiar with such kind of questions. So minus e2x cos x plus 2 is outside. First function integral of second is sin x minus integral differential of first is 2e2x into integral of second is sin x dx. Now clearly, if you remember, this becomes as same your integral. This is I, so it will become 2i. Okay, so it becomes minus e raised to power 2x cos x plus 2 e2x sin x minus 4 times I. So this was I, so I'll bring this 4i to that side. It will be 5i is equal to e2x is common, and you can take 2 sin x minus cos x. Okay, so I is e2x upon 5 into 2 sin x minus cos x. Right? So the constant of integration, we just need to put it back because I'm just solved with this. So I will come back to this equation number A. So A will imply y into e raised to power 2x is equal to e2x upon 5, 2 sin x minus cos x plus c. So y is equal to divide by e2x to this side. This is 1 by 5 times 2 sin x minus cos x plus c. So we will get upon e raised to power 2x, which can be written as e raised to power minus 2x, which is the required general solution of differential equation. Question number 4. Question number 4, clearly you can see it is of the form. It is linear differential equation of form your dy by dx plus py is equal to q. Right? P here is secant x and q here is tan x. So firstly we will find the integrating factor, which is e raised to power p dx, which is e raised to power secant x dx. So integral of secant x is your secant x tan x. Isn't it? The integral of secant x is log mod secant x plus tan x. Okay. So there is no need to put c here, and e and log are inverse function of each other. So we will just get the integrating factor as secant x plus tan x. Now solution is given by y into integrating factor is equal to integral q into integrating factor times dx plus c. So y into secant x plus tan x is equal to q. Q is tan x into secant x plus tan x dx plus c. So we get the integral here as secant x, and second one is tan square x. Right? So integral of secant x tan x is secant x, and for integrating tan square x we have to break it in this form plus c. So it becomes secant x plus tan x minus x plus c. Right? Now what we need to do is we just need to bring this secant x plus tan x down. Okay, so now we can get it as y is equal to secant x plus tan x, okay, minus x plus c upon secant x plus tan x. Okay, so this is the way how what we can do is either you can just adopt some other way. And what can I do is you take this term to other side. Okay, in that way it can be written as y times your y secant x plus tan x, okay, minus secant x plus tan x minus x plus c. So it becomes y minus 1 times secant x plus tan x is equal to minus x plus c, which is the required answer. Or you can bring this x to this side also. Let's take question number 7. Now question number 7 says, clearly you can see that it is not getting variables are separated, or you're not getting that your homogeneous system is framed here. But firstly you have to make this dy by dx free from the load that is there. So it will become your okay. So this becomes dy by dx plus 1 upon x log x by is equal to 2 upon x square. Okay, so clearly you can compare it with, as it is linear differential equation of form dy by dx plus py is equal to q. Okay, so p here is 1 upon x log x and q here is 2 upon x square. So integrating factor is e raised to power p dx, which is e raised to power x log x. So you know that it is just of the form f dash x upon fx, because if I put log x as t, so 1 upon x is, you can just side it out like this. So it becomes f dash x upon fx, right? So you know the integral is log mod, your fx will be log x. Okay, so e and log will just balance and we will get just log x. Okay, now solution is given by y into integrating factor is equal to q into integrating factor times dx plus c. Y into integrating factor q is 2 upon x square into integrating factor is log x dx plus c. Okay, now let us see how to integrate it. If you can take 2 outside, so you know that again here the product function is there, so we can use integration by parts. Integration by parts, first function is for log. This first function, integral of second, so x raised to power minus 2, integral will be x raised to power minus 1 upon minus 1 minus integral, differential of first is 1 upon x into integral of second is like this plus c. So it is 2 into minus log x upon x, log x upon x, and it becomes minus 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 plus, so it is 1 upon x square. Okay, which you can if clearly write it as you have to bring it up afterwards also. So this is minus 2 log x upon x plus 2 x raised to power minus 1 upon minus 1 plus c. So bring this log x to the denominator, it becomes minus 2 upon x, as log x upon log x will get cancelled, minus 2 upon x, and your we will get your log x to the denominator, so it will become log x plus c upon log x. Okay, so what we can do is we can take the x log x LCM, so x log x y is equal to, it will become minus 2 log, you are taking LCM, minus 2 and plus c x, which is the desired solution. Question number 8 is, again you have to express it in firstly dy by dx form, so that you can understand that what is the question here. So it becomes cot x minus 2xy dx. Okay, so if we frame dy by dx, I'll get it as cot x minus 2xy upon 1 plus x square. So it becomes dy by dx is equal to the term which is containing y, because we are getting for the form dy by dx plus py is equal to q. So involvement of y in which term is there, that will go to the left hand side, and the coefficient of x will be framing your q. So we can see clearly that what we are getting as p and what is as q. So it is linear differential equation of form dy by dx plus py is equal to q. P is equal to 2x upon 1 plus x square, and q here is cot x upon 1 plus x square. Integrating factor is e raised to power p dx, 2x upon 1 plus x square. So you can clearly see that it is f dash x upon your fx form. So I can just write it as your, this is as e raised to power log 1 plus x square. So I think it is clear to you. E and log will get cancelled, and 1 plus x square is the integrating factor. So solution is given by y into integrating factor is 1 plus x square, q into integrating factor is 1 plus x square times dx plus c. So who is q here? Cot x upon 1 plus x square into 1 plus x square dx plus c. So it becomes cot x. So what is the integral of cot x? Cot x is having integral log mod sin x plus c. So y can be written as log mod, or there is no need, as I think in whatever way it is expressed it is okay. So let's not bring it to the denominator. So it is log mod sin x plus c, which is the desired answer. Yes, see this equation carefully. Again you will just see that if I write dy by dx is equal to your x minus y minus xy cot x and divide by x, I will get something 1. Okay, this is 1 minus y upon x minus y cot x. Okay, so clearly from here you can see that as it is, if it is going to be of the form of dy by dx plus py is equal to q, so p will, the term which will be p will be having involvement of y. So I will get this, you can take minus sign common, minus y common, so 1 upon x plus your 1 upon x plus cot x, right? So we will get dy by dx plus 1 upon x plus cot x, right? Y is equal to 1. So this becomes, it is equation of form dy by dx plus py is equal to q. P is 1 upon x plus cot x, q is equal to your 1. So integrating factor is e raised to power this dx. Now we get, it is, as you know that it will be integrated separately. So the integral of this is log mod x and its integral is log mod sin x. So we will apply log a plus log b in the numerator, and it will be your log of e raised to power log of x sin x, which will be just x sin x, as e and log are inverse functions of each other. Okay, now solution is given by y into integrating factor, q into integrating factor times dx plus c. So y into x sin x is equal to, q here is 1, so it is x sin x dx plus c. Okay, so by parts I will use here. First function, integral of second is minus cos x. Okay, integral d dx of first is x, and integral of second is minus cos x dx plus c, which is minus x cos x plus integral of cos x dx plus c. This is minus x cos x, and this is your plus sin x plus c. X sin x, y is equal to minus x cos x plus sin x plus c upon x sin x. So x and x will cancel. So it will be minus cot x plus 1 upon x plus c upon x sin x. 13 is, see from here, from these differential equation given in exercises 13 to 15, find the particular solution. Particular solution which we get by giving the value of fixing the constant. Okay. So again clearly you can see that it is linear differential equation of form dy upon dx plus py is equal to q. Okay. So it is p is your here 2 tan x, you can see, and q here is sin x. So first of all find the integrating factor, which is e raised to power integral p dx, which is e raised to power 2 times tan x dx. So e raised to power 2, right? So tan x is your minus log mod cos x, which you can write it as that, it is, say, you can write it as that a log of secant x, or we can write it as log cos x raised to power minus 2. So e and log will get cancelled and it becomes your 1 upon cos square x, which can be termed as secant square x if required. Now solution is given by y into integrating factor is equal to integral q into integrating factor times dx plus c. So y into 1 upon cos square x is equal to q. Q is your sin x upon cos square x dx plus c. So this is sin upon cos is tan into secant x dx plus c. So it becomes y into your 1 upon cos square x is equal to secant x tan x integral is secant x plus c. Okay. Now to put the value y is equal to 0, x is equal to pi by 3. So it becomes 0 is equal to secant pi by 3 plus c. So this thing implies c is equal to secant pi by 3 is 2. Okay. So secant pi by 3 is 2. So 0 is equal to 2 plus c. So it implies c here will be minus 2. Okay. So now put back the value here. So 1 implies y secant square x is equal to secant x minus 2. Okay. Which can be written as y secant x upon secant square x minus 2 upon secant square x. Okay. So which becomes your cos x minus 2 cos square x, which is the required particular solution. Question number 15 here is, see from here, it is linear differential equation of form dy by dx plus py is equal to q. So p here is minus 3 cot x and q here is sin 2x. So integrating factor is e raised to power integral p dx. So p dx is minus 3 cot x dx. E raised to power minus 3, it is log of sin x. So again it is e log sin raised to power minus 3x. So I think it becomes 1 upon sin cube x. Okay. Now we have to find the solution is given by y into this integrating factor is equal to q into integrating factor times dx plus c. 2 sin x cos x upon sin cube x dx plus c. So this is y upon 2 times cos upon sin is cot x cosecant x. So you know that integral of cot and cosecant is your cot and cosecant is minus cosecant x plus c. Okay, and this y becomes as you can just, because here sine cube x will be multiplied, so we can write it as sine cube x plus c sine cube x. So it is minus 2 upon sine x into c sine cube x minus 2 sine square x plus c sine cube x y. So put y is equal to 2, x is equal to pi by 2. 2 is equal to minus 2 sine square pi by 2 plus c sine cube pi by 2 minus 2 plus c. C is equal to 4. Okay. So I'll just now put back here in the solution. I will get y is equal to minus 2 sine square x plus 4 sine cube x, which is the required solution. Question number 16 says, find the equation of curve passing through the origin given that the slope of the tangent, that is dy by dx, at any point xy is equal to the sum of coordinates. Okay, so dy by dx minus y is equal to x. So it is linear differential equation of form dy by dx plus py is equal to q. So p here is minus 1 and q here is x. So integrating factor is p dx e raised to power minus 1 dx, which is e raised to power minus x. So solution is given by y into integrating factor is equal to q into integrating factor times dx plus c. So better here we take the integrating factor e raised to power minus x as the second function and this as first function, because it will work as the integral will reduce easily. So first function integral of this is minus x upon minus 1 minus integral ddx of first is your 1 into e minus x upon minus 1 dx plus c. This is minus x e minus x, it's become plus e raised to power minus x dx plus c minus x e minus x minus e raised to power minus x upon minus 1 plus c. Okay, e minus x plus e raised to power minus x plus c. So y is equal to, this becomes, we are going to divide by e raised to power minus x. Okay, and it becomes e raised to power minus x, and then it becomes your, this sign here is going to be, as this sign was plus, so it is this, so it is minus here, just check it carefully. So it is your minus e minus x upon e minus x, which will be minus 1 and plus c upon e raised to power minus x. So be careful because just a mistake can lead to a wrong answer. Plus c e raised to power x. Okay, so we need to put one condition also in the question, that it is passing through origin. So passing through origin is x is 0, y is 0. We'll get 0 is equal to 0 minus 1 plus c e raised to power 0. So c is equal to 1. You can clearly see. So what is my answer going to be? Y is equal to minus x minus 1. Okay, and plus e raised to power x is the required answer. 17 is, find the equation of curve passing through the point 0, 2. Okay, so this point will act as the condition when x is 0, y is 2, which we will use for finding out the constant c. Given that the sum of the coordinates of any point, so if the point is your xy, then the sum of coordinates exceeds the magnitude of slope. So the magnitude of slope is dy by dx. Okay, exceeds the magnitude of your slope by 5. That means it is dy by dx plus 5. Okay, so let us change it to the proper form, dy by dx. Okay, because if it is differential equation of the form of dy by dx plus your py is equal to q, so definitely y will go to that side, so it will be minus 1 by, okay, and this 5 will go to other side, so it will be x minus 5. So clearly from here p is minus 1 and here q is x minus 5. So integrating factor here is e raised to power p dx, which is e raised to power minus 1 dx, which is equal to e raised to power minus x. So solution is given by y into integrating factor is this integral q. Q is your x minus 5 into e raised to power minus x dx plus c. Okay. So let us apply by parts here. So first function, second function. So this first function, integral of second is this, minus integral d dx of first is 1, and integral of this function is your minus e minus x upon minus 1 dx plus c. Okay. So it becomes y e raised to power minus x is x minus 5 e raised to power minus x upon minus 1. Okay. And that becomes plus e raised to power minus x dx plus c. So it is your, we will shift these terms so that the sign is settled. E minus x plus e raised to power minus x upon minus 1 plus c. So let us settle down, divide by e raised to power minus x, so it will become 5 minus x. Okay, it is 5 minus x, and this will be minus e raised to power minus x, so it will be minus 1 plus c. So let us put the condition x is 0, y is 2. So y is 2, x is 0, so it is 5 minus 1 plus c. So c is equal to 2 minus 4, which is minus 2. Okay, the equation becomes 5 minus x minus 1 minus 2. So I think it is clear that it is y is equal to your, the solution is given by your y into, we will put it here in the equation up here, this one. Okay, so y into e raised to power minus x is equal to 5 minus x into e raised to power minus x minus e raised to power minus x, and it is your minus 2. Okay, so we will simplify it. So y is equal to 5 minus x, and this is minus 1 minus 2. So we get it as your, so because I have to divide this 2 by e raised to power minus x also, so it will become your e raised to power minus x. Okay, so to the numerator it will be like this. So it is 4 minus x minus 2e raised to power x is the required solution. Equation, we need to check the integrating factor. So first of all, this differential equation is clearly of the form is equal to 2x. Okay, so it is linear differential equation of form dy by dx plus py is equal to q. So integrating factor here is of the form of e raised to power p dx. So clearly search for p, it is minus 1 upon x dx, which is minus log mod x, which is e raised to power log mod x raised to power minus 1. So I think 1 upon x is the required linear integrating factor. 19 is find the integrating factor of the following differential equation. So the differential equation here is your 1 minus y square dx upon dy plus yx is equal to ay, right? Ay, and this is the condition that your y is lying between minus 1 and 1. Okay, so to find the integrating factor, you firstly need to express it in the form of dx upon dy plus y upon 1 minus y square x is equal to ay upon 1 minus y square. So it is linear differential equation of which form? Dx upon dy plus px is equal to q. So p here is your y upon 1 minus y square, and integrating factor for such type of differential equation is e raised to power y upon 1 minus y square dy, right? So to integrate it, I know the derivative of this is minus 2y, so I'll multiply and divide by your minus 2. Okay, so this becomes e raised to power minus half log mod 1 minus y square, which can be written as e raised to power log 1 minus y square raised to power minus half. You cannot remove apply this inverse law if otherwise this negative sign is carried here. So it will be your 1 minus y square raised to power minus half, which is your 1 upon root 1 minus y square. Okay, which is the required integrating factor. So option number D is the correct answer.